dependent variable is some part of an experiment that depends on another variable, in this case, the number of rubber bands. Okay? So the distance that our Barbie doll or action figure falls is going to depend on how many rubber bands are tied to its ankles, yes? So that's how you figure that out, okay? So on our graph, again, dry mix, dependent variable on the y-axis, independent variable on the x-axis. That's how I remember anyway. You do what works for you, but you can put that in your notes if you'd like. We're going to learn about two terms today. One of them I think you've heard of. The other you probably have not, except if I said it yesterday. Okay? So let's say we've got some data points. And let's say with one rubber band, it barely falls at all. With two rubber bands, it falls this much. With four rubber bands, it falls this much. And then 5 rubber bands, it falls this much. And that's all the data we have. Okay? We stop our testing. We run out of time. Do we have time restrictions sometimes in life? Sure, we run out of time. So we have 4 data points collected. What do you notice about those 4 data points? 1, 2, 3, 4. What do you know about those 4? They're in a line. They look like they're in a straight line. Now, it might not be a perfectly straight line, but you could say that you have what we call a line. What am I going to say? A line of best fit. In mathematics, that's what we call a line of best fit. So what I can do is, using the data points that I have, I can make predictions about data that we don't have. Okay? And I say, well, if 1 rubber band got me here, 2 here, 4 here, wouldn't it make sense, wouldn't it stand to reason that if I had 3 rubber bands, it would probably fall that far? That prediction, based on the data you have, you're predicting inside of a data set that you have, is called an interpolation. You are interpolating. Ooh, that's good, huh? So, again, a prediction inside of a known data set. We didn't actually test this. We don't have the data, but we have data on either side of it, and we have a line of best fit. It stands to reason that's where it's going to be. Does that make sense? That's an interpolation, a prediction based on known data, and it's inside of that known data. What if I wanted to predict outside of the known data set? So if I wanted to know, how about 10 rubber bands? What is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rubber bands. Couldn't I predict that it would fall that far? 1.6 maybe meters, whatever it is.
Approximately.
That type of prediction outside of our known data points, that's called an extrapolation. So we are extrapolating when we're predicting outside of a known data set. Does that make sense? Okay? And if you look at the language, interpolate, extrapolate, inter means inside, right? Inside of. And ex means out of, yes? External, internal. Make sense? So those are the 2 terms I wanted to teach you today. Your graph is going to look very much like this. The only difference being, I want you to know how to do it analog style like this on your papers, but I also want you to do it in a spreadsheet. Okay? So we'll use Google Sheets. You, in 2 columns, will put your data points, and the program will make a graph for you. So it'll be prettier than all of this garbage. Does that make sense?
Yeah.
Okay. Any questions? Yes?